Okay. All right, inequalities. So we remember what inequalities are. They're these things. Remember these symbols from back in the day? Yeah. Unequal means something's greater than something, right? So less than or equal to, greater than or equal to, less than, greater than. All right? And all we're doing is graphing a line. That's an equation. But when we call it an inequality, we're talking about a set of points that are either less than or greater than the other side of that equation. Okay? So the important thing to remember whenever we're like working with these things, if we ever find ourselves doing this, if we ever find ourselves dividing or multiplying by a negative, we have to switch the direction of the sign. Okay? That's like important. And there's two methods to doing this. I'm really going to focus on the first one because I feel like this is the one they taught you when you were in Algebra 1, so that's the one you probably are most comfortable with. And then I'll touch on how to do it another way, okay? All right, but if there's a bar underneath your inequality sign, your line's going to be solid. Okay? You can think if there's a solid line in the inequality, there's a solid line on my graph. If there is no bar underneath, then our line will be dotted or I just dashed, whatever, okay? If we have a greater sign, then we're going to shade above. That's logical, right? Like greater above. And if we have a less symbol pointing to the left, we would shade below. But that's only for when we have slope-intercept or point-slope form. If you have a standard form, you have to convert it to y equals mx plus b, slope-intercept form. This whole little method is only going to work if you've got slope-intercept, or point-slope will work too, okay? So that's kind of like the little like asterisks. Like this works only if it's in this form. All right? So after we do that for our, if it's a system, we're going to have multiple inequalities. We look at the chunk of our grid that's shaded by all of our inequalities, and that's our solution region. Okay? And it's possible that those regions wouldn't ever touch. That's when we would have a no solution. Okay? All right, so let's try this first one. If I'm going to solve this one by graphing, this is in standard form, right? And if I have standard form, I got to convert it. So I'm going to go off to the side and convert it first. Okay, by now we should have been freshened up on that pretty good, right? So x is going to move to the other side. This minus sign, what is that sticking with? The x term or the y term? The y. It's with the negative 2y. So I still have negative 2y greater than or equal to. The x on the other side is going to change signs. It will be negative x minus 2. We all okay with that? Just moving that over. Okay. Now, to get y by itself, right, we would divide by negative 2, right? Okay. When I'm doing that, I have to be careful of something because I'm dividing by a negative. And what does that mean I have to do? I have to flip the sign. Does anybody know why? Like, I know that's what everybody tells you, but do you know why you do that? Just wondering. Okay. Well, you should probably know why you do something or else it doesn't make sense to do it, right? You do that, you flip this, because when you are dividing by a negative, you are applying an opposite to the whole statement, right? Isn't that what negative means? It means opposite. Well, inequalities have opposites. They can point the opposite direction. So that's why we have to flip it. So now, that's gone. I have y. This flips. It's now pointing the other way. Less than or equal to. Negative over negative. Doesn't that cancel out? And what's our m? Like, what do I put before x? Because I'm not going to write x over 2. I can't graph that. Yeah, that's just 1 over 2x. And then negatives cancel. That's plus. 2 over 2 is 1. Okay? So now I go to graph it. I just got to know how I graph it. I got to look, what kind of line am I going to have? Let's see. I I have a bar underneath my inequality sign, so it's going to be solid. So this is going to be a solid line. And my shading, let's see, it's a less than, so I would shade below my line. So I'm going to write solid, shade below. Okay? So I come over here, y-intercept of 1, slope of 1/2, so up 1, right 2. Down 1, left 2. Solid line. And shade below. Now when you go to shade this one with your pencil, just go real light, or if you have a pen, like just do little lines, because this isn't the final answer. This is one part. So I'm just going to go kind of lightly just to get an idea of where my solution or my solutions for this. So just so we're clear what this means, this is every point that's in this little shaded region, its y value is either equal to or less than half of the x value plus 1. So there could be many options for that. But now we're going to basically cross-reference it with this inequality. So I'm going to do the same thing with this one. I'm going to get y equals, right? Y by itself. So we're going to move the x to the other side. So y is less than or equal to. And remember, when x moves, it changes signs. So that's now negative x minus 1. And I see my y is already by itself, so I'm okay. I don't have to divide by anything. So I look, what kind of line am I going to have? Solid, right? And I look, where am I going to shade this? This is a less than direction, so I'm going to shade below. Okay? So y-intercept of -1, slope of -1, so I go down 1, right 1, right 1. Up 1, left 1. Except my line didn't quite hit those points down here. Oops. Alright, shade below. So I'm going to shade below this line. And you're going to notice when you start to shade that there is a chunk of your grid that's being shaded twice, right? When you see that, you have to go over with your pencil and you have to really carve that out. Really make it dark. Really make it obvious that this chunk is where your solutions are. They're all over here. This is called your solution region, or your feasible region. I think it's okay to call it solution region. Okay? And that's how you solve, right? In a system of equations, we could actually say what the answer is, right? We could put it in those little curly braces, those solution sets. We can't do that here because there's so many options. So our answer to this is a graph. Now what you can do is you can give some possible solutions. Okay? So possible solutions are you just pick a point that's within that region. Okay? So can anyone give us a point that's in the region? Andre, can you pick out any point that lies somewhere within that really dark area? Any point at all. Yeah, perfect. -1, -2 is right in there, right? All right. So what that means is that obviously that coordinate point's there, right? Also, if I were to plug in -1 for x and -2 for y, I would have a true inequality. the left side would be greater than or equal to the right, and same thing here, I would have something that works. Can anyone give us another one? Anyone? Negative 2, negative 4. All right. Negative 2, negative 4. All right, I'm going to ask you about one. I'm going to give you a point. What about negative 2, 0? What do you think? Negative 2, 0. Is that part of the solution region? Yes. Why yes? It's right here. It's on a solid line. Exactly. Okay? So if our point is on a solid line, it's good. It's a possible solution. But if our line was dashed, that's what differentiates solid between dash. Dash it wouldn't be. Okay? Okay, we okay with this? All right. I'm going to just briefly show you really quickly how to graph one in standard form by not converting it. Okay? And if you don't like this method, good news is you never ever have to do it. Okay? But some people want to see it, so I'm going to show it to them. So your other option, and I'm only going to do the top one just to save time. If you don't want to convert that to slope-intercept form, you could graph intercepts. Remember we did that second day of school, we covered up, find the, right? So like if I were to graph the x-intercept is 6, right? Y-intercept, also 6. Dashed line, because there's no bar, so I could just take this and make a dashed line. Okay. But I can't use the above-below rule, because that doesn't always work for standard form. Instead, what you do is you pick a test point. So you choose any point as a test point. I like to use 0, 0, this guy right here, because doing math with 0, 0 is easy, right? So you could plug in 0, 0 into that inequality. So for instance, I would say 0 plus 0 is greater than 6. And you ask yourself, is that a true statement? Is 0 plus 0 greater than 6? Well, 0 plus 0 is 0. Is 0 greater than 6? No. Okay? So what that means is that the correct side to shade doesn't have 0, 0 because 0, 0 didn't work. So that would mean that you would shade the other side. You'd shade up here. Okay? I don't know. Kind of think it's probably the same amount of work as converting to slope-intercept. It's just whatever you prefer. Okay? Whatever floats your boat. All right? We good so far? All right, let's do one more together, and then we'll let you try one, and I'll help you individually, okay? Let's look at example 3. Solving these by graphing. So here we got another standard form. You could do the intercept thing I just taught you, or I'm going to do the slope-intercept because that's a skill we got to make sure we're really good at, okay? So if I want to get this one, slope-intercept, x goes on the other side, right? Negative travels with the 3y. So negative 3y less than negative 4x plus 12. Okay. Then we're going to divide by negative 3. Do I have to flip my inequality sign? Yes. I divided by a negative, which means I'm making opposite the whole thing. So I got to point the opposite direction. Y is greater than 4/3 x. 12 divided by negative 3 is negative 4. Okay? Okay. No bar. So what kind of line am I going to have? Dashed or dotted, however you prefer to describe that. And the direction I'm going to shade is what? Shade above, which is different from the way the equation looked in the beginning, right? So that's why it's so important that we have to make sure we're changing it so we get the right direction. Okay, so I'm going to graph that. Negative 4, y-intercept, up 4, right 3. Okay, and then dash line. And then we shade below. Remember, go lightly because that's not the final answer, right? Oh wait, I'm a moron. Why did I shade below? Sorry about that. Did anybody notice I made a mistake? Okay, thank you. That happens all the time. Please speak up. I make a lot of mistakes all the time. So above. So we're going to shade above. That's why I like erasable pen. Happen to be using pencil today, but normally I have an erasable pen. All right, here we go. Was it this class that I numbered my number line wrong yesterday? I had 5, 6, 8, 9, 10. It's okay. I'm smart, I promise you guys. All right, there we go, shade above. Now what form is the second one in? Point slope. You're okay in point slope form. You can go ahead and graph it, and you don't have to convert this, okay? Because this is pretty easy to graph as it is, right? Instead of starting at the y-intercept, you're starting at a different point. We should be really good at identifying these points by now, right? What's that point that I start at that's given in the problem? Other way around.
Oh, wait, 5, negative 5 and 2.
Yeah, negative 5, 2, right? X1, bless you, Y1. Okay, so I'm going to start there, and I have a slope of 4/3. And then I can look at my symbol to determine what kind of line, right? So it'll be just like this one. It's going to be a dashed line. And we're going to shade how? Above. Okay. All right. So I start at negative 5, 2. Okay. And I'm going to go up 4, right 3. Dash line. And shade above. So you can kind of tell where the regions are, where the region is that has both, right? It's this chunk right here. So this is interesting because what kind of lines are those? They're parallel, and if this were a system of equations, there would be no solution, right? It'd be inconsistent. But with the inequalities, having a half plane that we're shading, we can actually have a solution, okay? So that's where our solution is, our solution region. Okay. What about any point on this boundary line? Would that be part of the solution? No, because it's dashed. Okay. All right, so I'm going to give you some time. I want you to try example 4. You do it the exact same way. It's just that there happens to be 3 of these. So your dark area will be the region shaded by all 3, okay? And I'll come around and help you all, and in a few minutes I'll show you what the answer was, what the answer is, okay? There it is. That's what you should have. So it should be this region right over here, okay? So the top one you had to convert. Y is greater than negative 2/3 x. 0, 0, down 2, right 3, all that good stuff. Greater than, so it's above that line. The middle inequality is ahoy. Horizontal, 0 slope, y equals 3, shaded below. So that's why this area got chopped off here, right? And then point at 2, 1, which is that point right there. And then we went up 1, right 2, shaded below, and then that's the chunk there. Got it, okay? So just be really clear when you're doing this where that is. Any questions I can answer for you? Or if you didn't get something, do you kind of see what it was? Advice, totally take it or leave it. This is just my advice. I would graph and shade, graph and shade, graph and shade. I wouldn't try to graph all the lines and then figure out the shading. I just feel like that's really confusing. But again, that's just my opinion. Okay, I'm going to let you practice another one in just a minute. Let's finish the notes with the last example, okay? All we're going to do here is come up, we're just going to write an inequality. We're not going to do the part where we're going to use the graphing calculator. We don't need to do that, okay? So we're not solving it, we're not graphing it, we're just setting it up. It says your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 seats, how many of each type of seat must they sell? Define the variables and write a system. Whenever a problem tells you to define the variables, you go back in the problem to the question, the part that has the question mark. How many of each type of seat? That's your variables. How many, so the number of each type of seat. Well, what types of seats do we have? What kind of seats are we selling to the show? There's the cheap seats and the good seats, right? Balcony and orchestra. Balcony, these people are sitting way up high in the back. Orchestra, these people are front and center, right? Okay, so we need to come up with variables. How about balcony? We want to use B. Sounds logical, right? B can equal the number of balcony seats. And I know it feels like we should use O for orchestra seats, but why might O not be a good choice? Because it looks like a 0. So I wouldn't use O. I don't know. What do you want to use? R, X, or C? Well, that looks like O times R times C. R, let's use R. Really wouldn't matter. If this were your paper, it wouldn't matter what you picked as long as you told me what you were picking and what it was standing for. Number of orchestra seats. Okay, so now we just go through and we put together the inequalities. So they're having a concert. They want to raise at least $30,000. Okay, this is talking about money, so I'm going to write an inequality about the money. So I see that we are charging $20 for a balcony seat. And I see we're charging $30, so plus 30, for an orchestra seat. And that has to be at least $30,000. What inequality symbol means at least? Greater than? It's a greater than or equal to. Okay? If you think about, like, you have to be at least 18 to vote, that means you could be 18 or older, right? Some people think least means less. That's not true. You really just have to understand the words, okay? All right, the center has 500 seats. So those seats are made up of B and R, right? So B plus R. Now this is not going to be an equation, so I'm not going to put equals 500. What inequality do you think we should put? Can they sell exactly 500 seats? Sure. Can they sell more than 500 seats? No. It's not possible. They can't, like, bring in a seat, right? Can they sell less? Yes. So our inequality would be what? Less than or equal to 500. And we will just end that one there. Okay? We'll just stop it there. All right. How are we going to put this in the notebook? We got to get a little creative because I didn't shrink this one down. Okay? Bless you. What I would do is I would fold this in half. So what we were just writing on is kind of on the outside. And then I would put some glue, kind of like in this white area that we didn't do anything with. And then I would stick it in the notebook so that it kind of looks like this. So you can still kind of open it up and see everything, but it's secured in there so it won't fall out. If you have a more clever way of attaching it, then more power to you. Do that. Okay? And then on tomorrow's quiz, you get to use this. So there are a couple inequality problems, but you do get to use this. And we're going to all together take some time to answer one more question. I want to make sure you really know what you're doing, okay? So when you finish this one, call me over to check it. But the one that I want to look at is on the sheet you picked up. This is a practice for everything pretty much we've been doing, okay? I want you to turn it to the back and look at number 7. Because I feel like that's a good one. It has kind of all 3 forms. You know, this one doesn't. Still a good problem. Let's all focus on this one, okay? Try to graph it. Make that solution region really dark. Call me over when you have it done and I'll check it for you. Once you have it done and good, then work on whatever you want to work on. You can work on the rest of this page, which is really good practice for your quiz tomorrow and the test coming up, or you can work on the graded work due tomorrow, okay? But call me over to see this first, and then you can break away to that. Also, if you have a question, I can come answer that, okay? And I can come fix that for you.